Part A, sketch the graph of y equals x times x plus 1 times x plus 3 squared. So the first thing I'm going to do is mark on the roots where the y coordinate is equal to 0. I can see that if x is 0, then the y coordinate would equal 0. Or if x plus 1 equaled 0, then the y coordinate would also equal 0. So the x plus 1 will be 0 if x is minus 1. Or if x plus 3 equals 0. So if x was minus 3. And minus 3 is a repeated root because of the squared there. Next, we need to consider the shape of this graph. It's a quartic function. If I was to expand all of this out, I'd have an x to the power 4, which means it's going to be a W shape if it's a positive x squared, or an M shape if it's going to be a negative x squared. Expanding all of this out will give me a plus x squared, so therefore I know it's going to be a W shape. So my graph is going to start by coming down. It's going to touch at the repeated root. It won't pass through because it's repeated. It's then going to come back up. It's going to have a turning point around here, pass through at minus 1, then another turning point, and then back up through at 1 there, at 0, sorry. So there's my sketch. Part B. Find the possible values of b such that the point 2, 0 lies on the curve with the equation y equals x plus b times x plus b plus 1 times x plus b plus 3 all squared. Now, because this is part B of the question, I'm immediately thinking that this is to do with my sketch. So I'm going to compare what I've just sketched here to the equation here. Let's compare those carefully. So what I've sketched had an x at the front, and this has an x plus b. Here I had an x plus 1, and here I've got an x plus b plus 1. Here I've got an x plus 3, and here I've got an x plus b plus 3. So actually, part B is exactly the same as part A, but with an x plus b substituted instead of the x. And we know what this plus b does. That just translates the graph b units in the x direction. So we are told that this point, the graph that we are looking at here, passes through the point 2, 0. So over here somewhere, 2, 0. And what value of b would make my function translate over to b passing through at point 2? So my function could shift over, right, so it was there, it could move over 1, 2 units like that, if b was negative 2. If it's going to move over 2 units in the positive direction, so 2 units in the positive direction, so it would be 1, 2, so it passes through at point 2, then b would be minus 2. So this is what would happen if b was minus 2. That's not the only way that my graph could translate and be at minus 2 though. It could also have been translated over 1, 2, 3 units like that if b was minus 3. There's one final option where actually if it had moved 3 units there, then another 2 units there if b was minus 5. If it shifted 5 squares over from here to here, that's moved 5 squares, so that would be where b is minus 5. So if b was minus 2, or if b was minus 3, or if b was minus 5, then this function would pass through the point 2, 0.